Most of us wouldn't give earthworms a second glance, but not Dr. Alice Wormius. Earthworms are her passion. You see, Alice is the curator of worms at the Australian Museum, and not only that, but she's the president of the Earthworm Society here in Melbourne. As Alice is about to reveal, there's far more to the humble earthworm than first meets the eye. Did you know there are over 6,000 worm species found on all continents except for Antarctica? Here in Australia, there are over 1,000 species of native worms and approximately 80 of which are introduced, but are still very beneficial to ecosystems. While earthworms might not be as photogenic as other majestic animals, they are vastly more important to the natural world because of the influence they have on how other organisms operate. Earthworms are amazing little creatures. They're sometimes referred to as ecosystem engineers because they significantly modify the physical, chemical, and biological properties of the soil profile. These modifications can influence the habitat and activities of other organisms within the soil ecosystem. Earthworms offer many benefits such as increased nutrient availability, better drainage by turning or aerating the soil, and bringing organic matter from the top to mix with the soil below. They are also the perfect food source for predators and are an important part of food web systems. Without earthworms, our soils would degrade considerably, causing flow-on negative effects for plant health, yield, and quality of produce. Many species from bees to humans would be severely affected. What we have here is the classic backyard earthworm. As you can see in this video, the motion of burrowing or squirming around is caused by a series of muscle contractions along the wall of the body, and it is what helps the worms to pass through the soil. By passing through the soil, earthworms leave behind nutrient-rich castings that are the product of digested organic materials. There is experimental evidence that microorganisms provide food for earthworms, helping them to grow. Protozoa and fungi are major sources of nutrients, while bacteria and algae are also a contributing food source. Symbiotic interactions between earthworms and microorganisms break down and fragment organic matter gradually, resulting in water-stable aggregates or masses. Their digestion unlocks important nutrients like nitrogen, phosphorus, and magnesium, making it a valuable type of fertilizer readily available to plants. Earthworms have complex interactions with microorganisms that can lessen or increase plant disease attack. This type of interaction is known as mutualism, as both species, earthworms and microorganisms, both have benefits. The earthworms feed on the organic matter, which helps them grow, whilst also helping the organic matter to break down and release nutrients back into the soil for plants to benefit from. This is a positive interaction. Worms are truly ancient species with evolutionary evidence showing their origins dating back to over 209 million years ago, making earthworms about as old as dinosaurs. From residing in the depths of the ocean where they absorbed and excreted nutrients beneficial to other sea creatures, they later developed adaptations by evolving tiny spikes, helping them to burrow into the ocean floor to protect themselves from predators in the evolutionary process. Current research indicates that earthworms belonging to the Lumbricidae family are extremely abundant in terrestrial temperate regions. They affect soil properties and nutrient cycling, thus shaping plant community composition and above-ground food web systems. Data indicates that their diversification was driven by tectonic processes and geological isolation around the time Laurasia landmass split away from Gondwana. Although there are many factors influencing the associations and activities of earthworms, there has been insufficient study into the influence of intra- and interspecific species interactions due to the high number of earthworm species. However, in soil conditions where one or more species of worms exist, it is found that the increase in population density usually negatively affects their growth, mortality, and fertility, including the number and size of cocoons produced. This is seen as having a negative effect on the intra-specific interaction between worm species, which is mostly determined by competition for space and resources. Well, I hope you enjoyed watching, and if you like it, don't forget to hit the subscribe button.